Okay, here this question says planet FLHS has a mass that is 2 times that of Earth and a radius that is 1.5 times that of Earth. What is the gravitational field strength on the surface of FLHS? So here's our planet, and we know that the mass is 2 times the mass of, I'm just going to use an E to abbreviate for Earth. And my radius is 1.5 times the radius of Earth. So the mass and the radius of Earth are given to you in your data booklet. So our mass of Earth and radius of Earth. If we write out our variables here, our mass of Earth is 5.98 times 10 to the 24 kilograms, and our radius of Earth is 6.37 times 10 to the 6 meters. So I know these two values. Now I just have to figure out what's 2 times that mass and what's 1.5 times that radius. So we can set up our equation. We're looking for gravitational field strength. G is equal to gravitational constant times mass divided by r squared. Our value for capital G, the gravitational constant, is given in our data books. It's 6.67 times 10 to the minus 11. And the units for this are Newton meter squared per kilogram squared. Now, I know that the mass is twice that of Earth, so I can substitute in here 2 times the mass of my Earth, which is 5.98 times 10 to the 24. And this is all divided by r squared, the radius of the Earth. So 6.37 times 10 to the 6 meters is my radius of Earth. I'm squaring this, but I want to multiply it by 1.5. Now, in order to type this into the calculator properly, it's really important that we use correct brackets and that we sub everything in right, or we're not going to get the correct answer, especially when you've got all of these numbers that are in scientific notation. So what you want to do is put all the terms in your numerator into one large set of brackets. So we'll open up a set, and we're going to enter our gravitational constant, 6.67 times 10 to the power of negative 11. Okay, then we're multiplying this value by 2, because we're going to multiply our mass of the Earth by 2. So I've got 2 times the mass of the Earth, 5.98 times 10 to the 24. Now that's all the terms in my numerator. Now I'm going to close that set of brackets around all of those terms and divide by, and I'm going to open up another set of brackets now because I've got 2 different numbers down here. I've got 1.5 times the radius of my Earth, and I want to make sure that I square that all as one term. So I've got 1.5 times the radius of the Earth, which is 6.37 times 10 to the 6. Okay, I close that bracket, and then I want to square the whole thing. So that's going to make sure that I square both of those terms together as one. And enter. Okay, and here's our value, 8.7366. So our units for this are Newton meters, or sorry, Newton kilograms, because we're measuring the gravitational field constant. So if I round this off, I'm going to get 8.74, and this is what I would record on my numeric response sheet. Okay, 8.74 would go on the numeric response, and my units for this would be Newton kilograms.